There's a graph, yeah? Okay. Not with the first homework, no?
No.
Just the second one. Okay. Okay, question 1. What do I tell you? What information do I give you?
TV. 200.
TV, yeah?
Volt.
How much?
120 volt.
Mm-hmm.
100 kilo.
No, just 100 watts.
100
kilowatt.
watts. Not kilo, I don't think.
No, it's just watt.
Was it?
Yeah. No, just watt.
Should be.
100
Yeah.
watt.
What's the current? Okay, which formula will we use here?
E equals I.
Nice and simple. I equals P over V, which equals?
0.4545.
Unit?
Ampere.
Okay, number 2. What do I give you?
10 ampere.
Okay.
And 200 volts.
Okay, and what do I want? Power? Oh, too easy. 2 kilowatts. Yeah?
2.2 kilowatts.
Is it 200 or 220?
220.
Oh, 220, okay. Right, number 3, what do I give you?
You say
Did I?
Yeah, you said it was difficult and don't do it, so I didn't.
No, I didn't. No, I said it was difficult. I didn't say don't do it though.
I interpreted it as don't do it.
No, that was not my intention. Okay, so let's do number 3 then. So an electric car moves at 20 by means of 5 kilonewton force. Okay, so you have your car. Where's my pen? There it is. No, I didn't stop. I just can't see it with the light.
No, pen is not working.
Oh, it is, but it's not moving.
So it's not working. Do you see
It's
the line?
slow.
The line.
Oh, now the light is off. Thank you. Now I'll have to close those. There we go. We're back. Okay. So you have your car. Its speed 20 meters per second, and the force of the engine. What's that? How much did I say it was?
5 kilonewtons.
5 kilonewtons. Yeah. So there was a little trick here for this. If you remember, power. Is that what I want? Isn't it power?
The resistance
Okay.
of the.
So first I need the power. Power is work over time. Remember?
Yeah.
But what's work? Force multiply distance over time. But what's distance divided by time? Velocity. So here it'll be 100 kilowatts, because it's 20 multiplied by 5,000. You have P equals IV, but I know the V, I know the P. Do I want the I? No, I don't want the I. What do I want? The or.
Yeah.
So if you remember your triangle,
V equals
I equals V over R. So you get P equals V squared over R. So R equals V squared over P. What's the V?
20.
No, it's the voltage.
Yeah, the voltage V, sorry. 276. 276 squared over 100,000. 0.76 amps. Did anybody actually get that? No, so everybody understood my it's very difficult to me and don't do it. Yeah, okay. In future, that's not what I mean. Alright? Okay, number 4. Yep. 2 ohm lamp uses a small capacitor to help maintain a constant energy flow. It takes 2 seconds for the capacitor to charge up and hold 100 millicoulombs. How much energy is stored?
The laptop.
Laptop, sorry, yeah. So you have 2 ohms, and the capacitor, what did I say? The Q equals 100 millicoulombs, is that right? And the time?
2 seconds.
2 seconds. Right. So we need to know what the resistance is in this circuit. We do know the resistance. It's 2. Yeah. We need to know the capacitance. Okay, so do you remember the formula? Time to discharge equals, how long does it take to fully discharge? 5 time constants. But what's the time constant equal to? RC. So C equals T over 5R. So capacitance equals 2 over 10, which is 0.2 farads. I forgot, what am I asking you for?
Energy stored in the
Oh, how
capacitor.
much energy? So the energy is a half CV squared. So we know the C, do we know the V? No, we don't.
No.
We don't know the V. Yeah. So we need a formula for V. Very good. Thank you. I'm very tired today. Q equals CV. So V equals Q over C. Great, let's just put that in. A half C Q squared over C squared. So the answer should be a half Q squared over C. Okay, let's calculate. Oh, thank you. 0.025 joules. 25 millijoules. Fantastic. Okay. Next question. A capacitor of 200 millifarads is charged and can do 2 joules of work. What is the voltage? So I can, which number is this? Number 5? It kind of, you're going to have to give me one now. Thank you. I can kind of cheat a little bit because I already have this formula from the last question, which is useful. E equals a half Q squared over C. And I want to know, oh no, not this one. I've used this one. E equals a half CV squared. So V would equal, let me see, 2E over C square root. Do I know the E? Do I know the energy?
2 joules.
And do I know the C?
Yes, 2000 millifarad.
2000 millifarads. 1.41 volts. Yep. Six. Flash camera, 5 joules of work, 100 milliseconds for 1.5 volt cells. Okay. Oh, sorry. Is it okay? think it might be at the other end, down here. There we go. Okay, let's have a look at the last one. We have our capacitor, bulb, and we have 4 cells. Each one is 1.5, so in total, what's the voltage here? The EMF in total?
Is it
6, correct, yes. 6 volts. How much work or energy has the light bulb done? It's 5 joules, was it?
Yeah.
What else do I give you?
The capacitance is 100 milliseconds.
100 milliseconds? The time to
Oh,
charge?
The time am I saying?
The time is 100,
Yeah.
so 0.1 of a second. So that means 5 time constants equals 0.1. So a time constant is 0.1 divided by 0.02 seconds. Okay. What else do I tell you, or is this it? Do I give you more information?
No, that's it.
That's everything? What do I want?
The capacitance of the capacitor was charged.
So you know that RC equals 0.02. So C equals 0.02 over R. So can we know the R? Well, we know the V. Oh, and we also know that a half CV squared equal to 5. Do we know? Oh, great. We can just use this one. Because we know this is a half C, 36 equals 5. Yeah?
Is one of the electric, no, one of the cell is 6.
No, one of them is 1.5, and there's 4 of them. Yeah. Right, so sorry, what am I saying? C equals 36 divided by 2 is 18, 5 divided by 18, so this is 0.278 farads. Yeah? Is that what I asked you for? Or do I ask for the resistance?
No, the capacitance of the capacitor.
Alright, that's too easy. I'll make it a little bit more difficult. Just a little bit. I'll ask you for the resistance in the light bulb. So I can put that in here, and I get R equals 0.02 over 0.278, and we get 0.072 ohms. Okay? I can close this?
Yeah.
Not yet. Next one was a graph. No graph?
Yeah. Okay.
You drew a graph? Show me. Is it beautiful?
It's ugly.
Oh, that is ugly.
I forget how to draw them.
Not bad. Nice. Did you draw a graph? Nicer than his, not as nice as hers. Yeah. Okay. I can close this and do the next one.